Gravity, according to Augmented Newtonian Dynamics. It governs the tides through the pull of the moon and stabilizes the orbit of the Earth around the Sun. Without gravity, there would be no structure to motion, no fixed cycles of day and night, and no conditions in which life could exist. Oceans would disperse into space, the atmosphere would vanish, and the Earth itself would disintegrate into fragments drifting apart. Stars and galaxies would never have formed, and the universe would be a thin, uniform haze rather than the structured cosmos we observe today. Therefore, gravity is not just an interesting phenomenon to be studied, it is vital for our very existence. Although rarely noticed in daily experience, gravity is universal and unceasing. It reveals itself in resistance, in the effort of lifting, in the inevitability of falling, in the constant experience of weight. This video begins by acknowledging gravity as the most familiar of forces, before examining in detail what this force truly is. For almost as long as mankind has existed, the phenomenon that is gravity has been a fascinating subject. What makes gravity work in the way it does? Why can't we harness the power of gravity as we have done with electricity? The discussion begins with the familiar pull of gravity experienced in daily life, then turns to Newton, who gave the first precise mathematical description of the force. His laws allowed the motions of planets and falling bodies to be predicted with remarkable accuracy, yet they offered no explanation for why matter should attract matter. Newton's gravity has no explanation for what gravity is. Einstein extended the description by linking gravity to the geometry of space and time, but again the underlying cause was left unresolved. Therefore, although we know enough about gravity to send spaceships to every part of the solar system, we do not know what causes gravity. Neither Einstein nor Newton explained what gravity is. Yet, we know that the same force that holds the Earth in orbit can, on larger scales, collapse stars and shape the most violent events in the universe. Augmented Newtonian Dynamics offers a new perspective. It seeks to address this question directly. It proposes that gravity arises from countless small alignments within a pervasive sea of photons, creating a universal but extremely weak tension. Each stage will be considered carefully, not only for what it explains, but also for what it leaves unanswered. According to Augmented Newtonian Dynamics, the virtual photon ether was created at the very beginning, in the moment of the Big Bang. That event is widely thought to have been accompanied by an immense release of light, flooding the infant universe with an almost inconceivable number of photons. As the cosmos expanded, these photons stretched with it, gradually losing energy until they became virtual photons of extremely low strength. Today, these low-energy photons permeate every part of the universe, forming what we now identify as dark matter. The need for this unseen component was first brought into focus by Dr. Vera Rubin, who showed that the rotational speeds of galaxies could not be explained by visible matter alone. Her work implied that about 85% of the universe's mass must be invisible. Later, more refined measurements raised that figure to 90% or more. In the AND view, this missing mass is nothing exotic. It is the all-pervasive sea of virtual photons created in the first light of the cosmos. Gravity is first encountered as weight, the effort of climbing stairs, the strain of lifting a heavy object, the ease of lifting a lighter object, the downward pull felt in every movement. A key feature in understanding gravity is that it acts on all masses in the same way. In a vacuum, a feather and a block of metal fall side by side with identical acceleration. This equality, confirmed in countless experiments, is one of the most striking properties of gravity. It suggests that gravity does not distinguish between objects, but acts as a universal influence. Newton explained this by noting that the force of gravity is proportional to mass, while the inertia that resists acceleration is also proportional to mass. The two effects cancel, leaving the same acceleration for all bodies. Einstein placed this observation at the heart of his equivalence principle, stating that gravitational mass and inertial mass are fundamentally the same. Another possibility, raised in later discussions of Mach's principle, is that inertia itself may be the result of the gravitational pull of all the matter in the universe. If every object resists motion because it is bound, however faintly, to the rest of the cosmos, then the balance between Earth's attraction inward and the universe's pull outward would scale equally for all masses. In this view, the universality of free fall is not a coincidence but the outcome of a cosmic balance, a profound hint that gravity connects every object not just to Earth, but to the whole universe. Newton gave gravity a language that could be calculated. Every mass attracts every other mass. Double one mass, and the pull doubles. Double the distance, and the pull is reduced to a quarter. This rule explains why apples fall and why moons orbit. Straight-line motion is gently curved into circles or ellipses by the force of attraction. The strength of Newton's insight was not only in the equation but in its universality. The same law applies from small objects on Earth to the motions of planets and stars. The tides can be understood as the moon pulling more strongly on the near side of Earth than the far side. Orbits are the balance between falling inward and moving forward. No mystical explanation was needed, only a single law that applies everywhere. His law explained the fall of bodies on Earth, the orbit of the moon, and the motion of the planets with a single formula that could be applied by anyone with paper and pen. It was a breakthrough in clarity and predictability. Yet Newton himself admitted he could not say what caused the attraction. His law described gravity with accuracy, but it did not explain its origin. Einstein also offered a description of gravity, but in contrast to Newton's simple equation, the mathematics of general relativity is so complex that it only became practical with the advent of modern computers. In this view, the concept of a pull is replaced by the geometry of space and time. Matter bends spacetime, and curved spacetime determines how matter moves. The apple and the moon are not drawn downward by a force but follow natural paths through a distorted geometry. This framework accounted for certain observations, such as the bending of starlight around the Sun and the gradual precession of Mercury's orbit, although recent studies suggest Mercury's semi-liquid core may play a role in its precession. The slowing of clocks at lower altitudes is also often cited as evidence for Einstein's theory, yet it can be understood equally well in Newtonian terms as a consequence of gravitational potential. Geometry, not force, became Einstein's language of gravity, but the central question remained unresolved: what is gravity itself, and why does matter exert such an influence at all? Einstein had no explanation for the origin of gravity. Newton and Einstein each gave gravity a description. Newton expressed it as a universal law of attraction, precise enough to predict the motion of planets and the fall of an apple. Einstein reframed it as the curvature of space and time, able to account for phenomena Newton's laws could not seemingly explain. Yet for all their success, both accounts stop short of the central question: why does gravity exist at all? What mechanism produces this constant and universal pull? Augmented Newtonian Dynamics proposes an answer. In this framework, gravity is not a fundamental force but the emergent result of matter interacting with a pervasive photon sea. Electrons, in their continual process of emitting and reabsorbing photons to stabilize their energy, align this medium in fleeting but orderly ways. The combined effect of countless such alignments, repeated without pause, is the weak but relentless attraction recognized as gravity. The standard model of quantum mechanics attempts to explain light and matter by introducing wave-particle duality. In this view, electrons are sometimes particles and sometimes waves, existing in superpositions across multiple spatial dimensions until observed. This description is mathematically elaborate but conceptually unsatisfying. It leaves light unreal between emission and detection, and portrays electrons as probability clouds rather than physical entities. In classical physics it was accepted that charged particles, whether bound or free, emit radiation whenever they are accelerated. If the electron were truly a small particle orbiting the nucleus, it would always be in an accelerated state and should therefore radiate away its energy, spiraling into the nucleus within a few trillionths of a second. Yet observation showed that atoms are stable and electrons do not collapse. To resolve this contradiction, the Standard Model redefined bound electrons not as particles but as waves. In this view, electrons form standing waves described by a mathematical wave function. The framework of wave-particle duality was then extended to both light and matter. Entities are sometimes particles, sometimes waves, existing as superpositions across multiple dimensions until observed. This construction is mathematically elaborate but conceptually unsatisfying, for it leaves light unreal between emission and detection and reduces electrons to probability clouds rather than physical entities. Augmented Newtonian dynamics rejects this interpretation. It treats electrons as real particles and photons as real quanta with structure. The photon is understood as an electric dipole, a pulse of electric energy separated by empty space acting as a dielectric. When electrons emit photons, they do so in connected trains at astonishing rates, hundreds of trillions per second, giving rise to the observable radiation of light, radio, and other electromagnetic waves. The key factor that makes the augmented Newtonian dynamics theory of gravity possible is the physical structure that in theory has evolved for the photon. In order to understand the augmented Newtonian dynamics theory of gravity, it is necessary to first understand that AND theory rejects the standard model theory of wave-particle duality. In formulating a structure for the photon, it was reasoned that since the electron is a charged particle, what could be more natural than that it maintains its energy through the absorption or emission of pulses of electric energy. The initial pulses of electrical energy emitted by the photon are stronger than subsequent pulses of electrical energy emitted by the electron. This difference in energy levels would polarize the train of pulses, producing a stable configuration in the form of an electric dipole. That dipole was the complete photon. The advantages of such a structure are considerable. First, it allows an electron to emit or absorb a photon of the required energy in femtoseconds, matching the speeds demanded by modern technology. Second, the structure gives the electron fine control over both emission and absorption energies, ensuring precise interactions. Most importantly, the model endows the photon with physical dimensions. In this framework, a photon has a diameter of about 10 to the power of -16 meters, small enough for electrons to exchange them rapidly in a one-to-one process. This structure also accounts for the observed properties of light. It explains photon frequency, the linear propagation of light, the spreading of intensity according to the inverse square law, its lack of rest mass, its ability to preserve energy intact across cosmic distances, and its constant speed of 299,792,000 meters per second. In this way, the photon is not only given a concrete form, but this structure also accounts for the multiple observed properties of light. At the same time, bound electrons carry out a second process. In order to maintain their stability in orbit around the nucleus, they engage in virtual self-interaction, emitting and immediately reabsorbing photons. These emissions do not travel outward as radiation but momentarily align the surrounding photon sea. They create temporary lines of force that define the shortest path between objects. Though each interaction is fleeting and carries no net energy transfer, the sheer number of these self-interactions produces a persistent but extremely weak influence, the phenomenon recognized as gravity. It should be noted that the standard model posits photons as excitations of a quantum field, abstract entities defined far from the point of interaction. In this view, the photon is not a concrete particle but a ripple in an invisible background, only manifesting when exchanged. AND theory rejects this notion and holds instead that photons are formed within the electron itself, created, emitted, and reabsorbed in direct one-to-one processes. In this framework, the photon is not a distant field excitation but a physical carrier of energy, intimately tied to the electron that produces it. Two distinct processes must be distinguished. The first is the regular emission and absorption of photons in continuous chains, forming all observable radiation. This process explains both the rectilinear propagation of light and its obedience to the inverse square law. An electron orbiting the nucleus at a given energy level absorbs a photon appropriate to that level. The added energy drives the electron inward toward the nucleus, where it rebounds according to the classical law of recoil. The angle of incidence equals the angle of reflection. Experiments beginning with Rutherford scattering studies confirmed that electrons do indeed interact with the nucleus in this direct way. When the electron returns to its original energy level, it re-emits a photon identical to the one it had absorbed. The recoil from this emission causes the electron to retrace its path until it reaches its initial position, where it absorbs another photon and the cycle begins again. This sequence is repeated at the rate of hundreds of trillions of times per second. In augmented Newtonian dynamics, the frequency of a photon is thus the rate at which it is emitted. The sheer scale and rate of the emitted photons account for light following the inverse square law. The second process involves the continual virtual self-interaction of electrons, which stabilizes their motion within atoms. Through the constant emission and reabsorption of photons, the electron regulates its own energy and prevents its collapse into the nucleus. This self-regulation is closely analogous to the way the nucleus is stabilized by the continuous exchange of massless gauge particles known as gluons. Each time an electron emits and reabsorbs a photon in this virtual cycle, it briefly forms a line of force. Such a line exists only for an infinitesimal moment and does not convey energy. Yet if the line of force intersects another object, a reciprocal line is created, linking the two objects. These alignments represent the shortest distance between the objects and produce a minute attractive effect. Because the electron emits and absorbs photons isotropically, in all directions, no single concentrated line forms. Instead, the effect is spread over countless individual interactions. Each electron resembles a microscopic neutron star, endlessly emitting lines of force in all directions. These are not streams of energy but fleeting alignments in the photon ether, created in the moment a virtual photon is emitted and reabsorbed. Most vanish instantly, but when such a line encounters another object, it is matched by a reciprocal alignment, producing a minute attraction. The effect of a single electron is vanishingly small, yet the combined action of countless electrons, all radiating their virtual alignments like microscopic neutron stars, gives rise to the universal and unceasing pull we call gravity. From this, gravity emerges. It is the cumulative result of innumerable fleeting alignments within the photon ether. The weakness of gravity compared to electromagnetism, about 10 to the power of 40 times smaller, follows naturally, for each alignment is virtual and without direct energy transfer. But despite its weakness, the process is unceasing and universal, giving rise to a force that extends across the entire cosmos. The stabilizing cycle of virtual photons is continuous. Therefore, gravity is continuous. These fleeting exchanges take place on intervals so short, and with energies so finely balanced, that they never appear as real. Yet when an electron is disturbed by incoming radiation, photons, a distinction becomes clear. The electron responds differently to interactions that are slightly longer or more energetic than its stabilizing rhythm. It can differentiate between the two, one belongs to the background of stability, the other to the outward flow of radiation. What we call virtual and real photons are not separate processes but two expressions of the same principle, distinguished only by their scale in energy and time. The two processes are complementary. One, virtual photon exchange, is the hidden background stabilization mechanism that produces gravity. The other, real photon emission absorption at terahertz rates, is the active process by which electrons exchange measurable energy. They coexist continuously, not interfering, but expressing different facets of the same underlying behavior. Finally, imagine standing at a window, looking out on a garden radiant with color on a bright, sunny day. Which framework truly explains what makes this image possible? Is it the standard model, with its wave functions and infinite dimensional abstractions that render light unreal between emission and detection? Or is it augmented Newtonian dynamics, which describes each color as the product of hundreds of trillions of photon emissions every second, streaming directly to your eye? The same contrast applies to gravity. And theory provides a subtle and unified model that operates across immeasurable distances as well as at the smallest scales. By contrast, quantum mechanics offers no account of gravity at all, leaving the explanation to general relativity. Consider the difference. And theory offers a mechanism rooted in the very heart of matter, capable of distinguishing the gravity of a feather from that of a ball of iron. Which makes more sense, a framework that treats light and gravity as unreal or undefined, or one that ties them seamlessly together into a physical explanation that works from the subatomic to the cosmic? The augmented Newtonian dynamics account of gravity works flawlessly wherever atoms and electrons exist, from the everyday scale of falling objects to the motions of distant galaxies billions of light-years away. In every case, the continual self-interaction of electrons with the photon sea provides a consistent explanation for the pull of gravity. But there are regions where this process cannot operate. In neutron stars, matter takes on a very different form. At such densities, atoms are crushed, nuclei dissolve, and electrons are forced into protons to form neutrons. With no orbiting electrons, the familiar mechanism of virtual lines of force disappears. If gravity is still present there, and observations show it is, then a different process must be at work. Gravity shapes the lives of stars as surely as it shapes the fall of an apple. A star begins as a cloud of gas and dust drawn together by gravity. In its long middle age, nuclear fusion pushes outward while gravity pulls inward, and for millions or billions of years, a balance holds. But when the fuel is gone, gravity takes command, and the star's fate is decided by its mass. In smaller stars, gravity cannot overcome the pressure of electrons. The result is a white dwarf, a dense core less than about 1.4 times the mass of the Sun, supported by electron degeneracy pressure. In larger stars, the balance tips differently. Their cores collapse beyond this Chandrasekhar limit, crushing electrons into protons and forming neutrons. The outcome is a neutron star, a body so dense that a teaspoon of its matter would weigh billions of tons. And if the original star is massive enough, the remnant core itself exceeds even the resistance of neutrons. The collapse continues without limit, and a black hole is formed, an object where gravity overwhelms all other forces and not even light can escape. In each of these transformations, gravity is the decisive force. It sculpts the quiet death of a white dwarf, unleashes the fury of a supernova, and creates the most extreme objects in the universe. But for augmented Newtonian dynamics, the case of the neutron star presents a puzzle. Here, atoms no longer exist, nuclei are dissolved, and electrons have been consumed into neutrons. With no electrons, the familiar mechanism of virtual photon self-interaction cannot operate. Yet gravity not only persists, it grows stronger. To understand this regime, we must look beyond photons, to the most elusive particle of all, the neutrino. In the augmented Newtonian dynamics view, the neutrino is a massless gauge particle, similar in kind to the photon. When a photon interacts virtually, it creates a fleeting line of force, energetic but so short-lived that it remains undetectable. Neutrinos, by contrast, emerge only in violent events such as the destruction of a nucleus. They carry far more energy than photons, yet their action is a single, one-off release rather than a continuous cycle. Unlike photons, which engage in self-interactions hundreds of trillions of times per second, neutrinos flash into existence in rare, catastrophic moments, forming lines of force that vanish as suddenly as they appear. A neutrino line of force exists for only 10 to the power of -18 seconds. A neutron star left alone in deep space may do nothing dramatic. In its youth it can shed energy violently, releasing torrents of neutrinos and magnetic storms that briefly make it a magnetar. Yet this furious phase cannot last. The star cools, it spins more slowly, and with time it becomes a silent remnant. Neutrons are not perfectly stable, but under such immense density their decay is suppressed. Without external disturbance, the star endures as an extremely dense relic, destined eventually to fade into obscurity. The story changes completely when a neutron star lies close to another star. In this environment, neutrinos are no longer the rare, ghost-like byproducts of nuclear reactions. In a neutron star, they are produced in torrents, filling every cubic centimeter in unimaginable numbers. Under normal conditions, neutrinos slip through matter without effect. But here, their density is so great that their fleeting alignments weave a new lattice of force. This is supergravity, an emergent pull not from electrons and photons, but from floods of neutrinos. It is immensely destructive. Supergravity tears at a companion star, drawing matter off in filaments like smoke in a gale, spiraling inward toward the neutron star. The feeding accelerates, the mass of the neutron star swells, and at last the system destabilizes. The outer layers erupt outward in a violent blast, while the core is crushed inward by overwhelming supergravity. Collapse becomes unstoppable. The remnant implodes beyond every limit, leaving behind not a star but a black hole, a region where supergravity rules absolutely, and not even light can escape. In augmented Newtonian dynamics, the principle is the same across all regimes. Gravity arises from virtual lines of force, fleeting alignments in the photon sea. In ordinary matter, electrons and photons provide the interactions, creating the gentle and universal pull we experience every day. In neutron stars, where electrons no longer exist, torrents of neutrinos take their place, creating alignments of far higher energy, the destructive pull of supergravity. Different particles and different energies give rise to different kinds of virtual lines of force, but the mechanism is one. Matter interacts with the ether, and the result is gravity. For centuries, gravity has been described with precision but left without a physical cause. Augmented Newtonian dynamics supplies that cause. Electrons in bound matter continually emit and reabsorb photons in virtual self-interaction, momentarily aligning the surrounding photon sea into evanescent lines of force. The sum of these alignments produces a weak, universal attraction that thins with distance and yields the inverse square law without altering any constants. In extreme environments where electrons and atoms no longer exist, the same principle persists with a different carrier. Neutrinos are produced in immense numbers. Their fleeting alignments generate a far more intense regime, supergravity, capable of driving the violent behavior of compact objects. Ordinary gravity and supergravity are thus two expressions of one mechanism, virtual lines of force formed in a universal medium. This picture does not discard Newton's law or Einstein's geometry, it contains them as successful limits while providing the missing y. The orbits remain the same, the numbers remain the same. What changes is that the pull is traced to specific physical interactions. The standard for acceptance is not rhetoric but accord with observation. A theory that preserves established results, reduces assumptions, and accounts for gravity with a concrete microphysical process deserves careful consideration. If gravity can be shown to arise from how matter continuously retunes its medium, gently in ordinary matter, violently in the densest remnants, then the most familiar influence in nature finally has a cause. The end.